This is the last problem that we're going to be working on for decay and growth. In this particular problem, we have sheep that have decayed over the years. So their population is shrinking. So the U.S. population of the bighorn sheep was 1,170 about in 1971. And by 1999, only 335 remained. And you can actually Google this, and there's information on the internet that actually backs this up. This is real life data, which makes it a little bit more interesting. I like this problem because of that. Write an exponential equation to model the decline in the population. So you first have to find k, then write the particular equation. So this is going to be something that you can try. So you're going to try this, and then you're going to see if you can even find the year that only 5 bighorn sheep, not sheeped, sheep, 5 bighorn sheep remain in the U.S. So see if you can find that approximated year in which that's going to happen. And when you're ready, press play and come on back, and I'll be going over it with you. Okay, so our exponential equation to model the decline is going to look something like this. We have to first find k. So we're going to start with our end value of 335. Our initial value is 1170. And that happens over a period of, it looks like 28 years. So e raised to the k times 28, or you could say 28k. We're going to divide both sides by 1170, divide both sides by 1170, and we get this fraction is going to be our argument of our logarithm. So we're going to have log base e, which is natural log, of 335 over 1170 equals 28 times k. Divide both sides by 28, and on paper k is approximately negative 0.0447. So this is on paper. Now I'm going to put this into my calculator, and I'm going to store it. So I've got the natural log of 335 divided by 1170, and take that divided by 28, and I store it, and we're good to go. What year might only 5, oh, not done. Then write, let's do this, then write the particular equation. So the end value is going to change. The initial value in 1971 does not, times e raised to the negative 0.0447 t power. So the two things that are changing are time and the end quantity of sheep. So what year might only 5 remain? So we've got 5 equals 1170 times e raised to the negative 0.0447 t power, and we need to solve for t. I'm also keeping in mind that I've stored this value as k. So I divide both sides by 1170. That actually gives me a percentage is equal to e raised to the kt power. So I've got the natural log of that percentage that remains. So the percentage remaining would be 5 out of 1170. So the natural log of that percentage is equal to k times t. We're going to divide both sides by that stored value of k. And the time, if I use the stored value of k, natural log of 5 divided by 1170, divide that by the stored value of k, and I get 122.138 sheep, which is not possible. So we'll say approximately, oh, it's not sheep, it's years. We solved for t. T is time, not sheep. So that would be years after 1971. So if I add that number to 1971, I get 2094 because it's past 2093. I got 2000 93.137783, which is past 2093. Therefore, we're going to be in 2094. That's what I got. Now, it might be just easier for you to say 128, let's not box that like that, 122.138 years after 1971. That might be a little bit better, more clear. This is clearer than the actual year. But you have to label it with all those words. You can't just say 122.138 years. You have to say 122.138 years after 1971. Now, if you did not use the exact value, you probably got about 122.043. Yeah, about 122.043 years later. So that's it. So if you got those answers, I think you should be feeling very good about these problems, the growth and decay problems. Remember, growth constant, K is positive. Decay constant, K is negative. You can see that we're dealing with exponential problems along with logarithmic problems, and it takes everything that we've done from the very first lesson all throughout this entire chapter and applies it all. It's in an interesting way with the sheep. So hopefully you've enjoyed this video and you feel good about what you're able to do.